Hello class, let's start the experiment. As you can see, all the cables are connected, the flow sensor is connected, the white cable, all the green thermometer cables are connected from T1 to T8, and one of the specimen is placed at the linear heat conduction column. As you can see, this is 25 millimeter brass. So let's start the experiment. I'm going to start the experiment by turning on the main switch. As you may see, the flow for the cooling system start working, and we have cooling operation started. Okay, let's start first by adjusting the voltage. So I'm going to rotate this knob, selector knob, and show the voltage, and it's 9.9. With this volume, I'm going to increase it to too much, to 10. Okay, it's 10, and we can record voltage is 10 and amp is 0.96. Because this lab temperature is 21 degree, as you can see, the current temperature for T8, all the thermocouples, when I'm using this knob, is around 21, and the hottest part is the top part, which is for T1, and it's getting higher and higher. For example, T1 is 26 now, T2 is 25, and as you can see, it gradually decreases till T8. If I select T9, it's going to show 145, which is error. We don't have that temperature, and I haven't connected anything to T9. So T1 to T8. So now we need to wait for the apparatus to reach steady state. Usually it takes 20 to 40 minutes, depends on the room temperature and what is the voltage or the power we are putting for the heater. So I'm going to monitor T1 to T8 after maybe 20 minutes and check if the temperature variation is very small, and during like a last 1 minute if I have any temperature change or not. If the temperature was stable, I'm going to record T1 to T8 by this knobs, selector knob, and plus the voltage and amp. Currently amp is 0.99 and voltage is 10. It is going to fluctuate, so you can have this you can consider part of the error in our calculation. So I'm going to pause now, and after 30 minutes come back and check the temperatures. Okay class, now it is after almost 40 minutes, more than 40 minutes later. I waited to reach a steady state, and as you can see, the temperature is not fluctuating that much, and increasing temperature rate is very small. But because this room has aircon, so we're never going to reach steady state. So after 40 minutes, I'm going to read T1 to T8, but because I want to decrease the effect of temperature increase and have all the data at the same moment. So this reading temperature processes must be very fast. So I'm going to read temperature T1 to T8 very fast to neglect temperature increase when I'm reading different temperature for the different thermocouples. Okay, let's wait to increase this 72 to 72.5. As you can see, it's really good. Okay, we reached 75. Now I'm going to read T1 is 72.5, T2 is 70.6, T6 is 68.7, T4 65.9, T5 64.8, T6 is 24.5, T7 is 23.2, and finally T8 is 22.9. So let's see. Yeah, T8 is 22.9. So let's check the voltage is 10 and amp is 0.96 maybe. And let's check the flow rate. The flow rate is 0.61 liter per minute. So 0.61 for your notes. And let's go back here. The specimen was 25 millimeter brass case. Okay, now I'm going to change the voltage from 10 to 7. So let's rotate this selector knob to voltage and decrease the voltage to 7. And okay, it's 7 and amp is 0.66. Again, we are going to wait about 40 minutes to reach a steady state and read T1 to T8 for the same specimen, which is brass with 25 millimeter diameter. So I'm going to pause and wait to reach a steady state. Okay, class, it's about 50 minutes later. Temperature is almost stable and we can say we're around steady state and condition. Let's read the temperatures T1 to T8. So let's see, T1 is 55.9, T2 is 54.8, T3 53.6, T4 is 51.5, T5 is 50.7, T6 is about 23.9, T7 is 22.9, and finally T8 is 23, and the voltage is 7 and amp is 0.64. Again, flow, because our water is connected to the tab, it's about 0.56 liter per minute. Okay, now we have two sets of data for the brass when we had 10 voltage and 7 voltage. Now I'm going to turn off the controlling system, wait a little bit to cool it down, and open these clamp and replace brass specimen with aluminum, this one with the same diameter. Okay, the column is cool enough to open and it's safe. So I'm going to open this clamp, front side and back side. Put this one aside. Now I need to open these two thermocouples and replace with aluminum one, which is here. So let's do it. It's very easy. We need to rotate this to open thermocouple. Okay, so you can see the tip for the temperature sensor here. Oh, wrong way. Okay, let me open this with two hands and then come back. Okay, thermocouple number 4 and 5. Now it's out of the brass specimen, and we are going to place them inside the aluminum specimen at these positions. So I'm going to screw them in, one at the top one, number 4, and number 5 here at the bottom side. So let me do it with two hands and then come back. Okay, thermocouples are inside the specimen. I'm going to place it on the linear conduction column and place the heating section, the upper section, over it. Close the clamp in the front side and back side. Now we have the new specimen, which is 25 millimeter diameter aluminum. Let's turn on the controlling system. For the voltage, I'm going to adjust for 10 volt, similar to the previous case. So we are very close. It's 10 and amp is 0.95, and again the same procedure. We are going to wait till reaching steady state or close to the steady state. This case is for aluminum. Let's wait and around 50 minutes, and then I'm going to come back. Hello class, again 50 minutes passed and we are around steady state for aluminum when we have 10 volts. So let's start reading as fast as possible. So T1 is 61.5, T2 59.2, T3 56.9, T4 is 51.5, T5 is 49.5, T6 is 27.6, T7 is 25.6, and finally T8 is 24.7 or 8. Okay, now we have all the data for this case, and I'm going to change the voltage. Let's check the voltage. It's 10 volt and amp is 0.95. We can check flow rate. It is 0.57 liter per minute. Now let's change the voltage from 10 to 7. So I'm going to decrease the voltage to have a lower power for the heater. So it is 7 volt and amp is 0.68. And again, let's wait 50 minutes or even more to reach steady state. I'm going to pause and come back when we reach steady state. Hello class, 50 minutes passed and I'm back to read temperature T1 to T8 when the voltage is 7 and amp is 6.8. So T1 is 49.3, T2 47.9, T3 46.5, T4 43.3, T5 exact 42, T6 25.9, T7 24.5, and finally T8 24.1. Let's check the flow rate. Okay, flow rate is 0.56 liter per minute. Now we have all the data for two cases of 7 and 10 volts for aluminum and brass with same diameter of 25 millimeter.